Hi everyone, welcome to the Enhancing Clinical Practice and Outcomes stream of the SNOMED CT Expo 2021. My name is Kathy Richardson and I'm a Senior Terminologist at SNOMED International. I'll be moderating today's session. Please use the live Q&A in your AirTouch device to type your questions to the presenter. All questions will be answered at the conclusion of this presentation. I'm now pleased to introduce Matt Cordell from CSIRO, who will be presenting Exploring Data Analytics with Historical SNOMED CT Datasets. Matt, over to you. Please proceed.
Thanks, Kathy. Good day, everyone. Thank you for joining us for this presentation I've got. Today we'll be looking at just touching on some ideas of how we can work with analytics on a historical data set. There's a real lot to get through here, so apologies for the speed, but hopefully you'll take away a few messages from this. So getting into it, I'll just introduce the data set that we're working with for this project. It's a synthetic data set, so there's no real patient data, but it was generated off statistics from the Australian Institute of Health and Welfare. And we used an open source application called Cynthia to generate what ended up being just over 200,000 encounters for injuries for patients. And this gave us a set, 200,000 encounters, and that covered nearly 9,000 unique SNOMED codes. We generated this data off the February release of SNOMED CT-AU, and that's based off the international July release from 2019. We chose this historical one so that we've got a time frame of 2 years. We've got 4 major international releases within this time frame. The kinds of concepts within our data set cover diseases, events, and situations with explicit context, so we've got quite a variety of stuff here. Just to give you an idea of the kind of distribution, this is just a rough injury report that we can generate off the data, showing that we've got some male-female differences across the 9 categories, and then a 10th category for uncategorized, and that's anything that didn't fit into our categories. So the process that I've used for this, we rely on a terminology server, a FHIR terminology server specifically, being CSIRO's Onto server. That provides our services to do code lookups and value set expansions. So our first thing was we defined some aggregation categories that we want to do our analytics on. And these were bespoke. We've made them up ourselves, and they're based off the expression constraint language. We use the terminology server to perform value set expansions of the CCL, and we store these on the client side, at least this initial process. And then we go through each of the encounters and check if the code that they've got against them is within one of those categories. And if they do, it gets categorized as that. Yeah. So analytics over time, that's when it gets interesting. You're doing the analytics on one set of data at one point in time. When you know the version that you're working with, that's fine. But one of the strengths in SNOMED is that it is an evolving terminology, and traditionally it's there've been at least 2 major releases every year, and that's moving forward to more frequent releases coming up. So that just means that there's more opportunities for change, and we need to take these into consideration, especially when we're doing things like comparing annual reports. We want to make sure that the kind of aggregations we're doing from one year to the next are comparing apples with apples. We're not losing information. Similarly with longitudinal data sets, if we're identifying patient cohorts, we want to make sure that we're keeping those patients and they're not dropping off due to changes in how we're identifying them as a result of terminology changes. And similarly, I guess the overall aggregation categories, we want to simultaneously make sure that they stay consistent over time, and that our definitions of these categories might need to evolve to respond to the terminology changes as well. So we'll go through all these and see how the impacts these have if we don't do anything, and some gradual steps we can do to improve them. So what should you expect and prepare for? The first and most obvious thing will be inactive concepts, and that shouldn't be a surprise that we're going to have inactive concepts in a data set that's generated from 2 years ago. So we'll deal with those first. Then there's hierarchical changes that can produce different aggregations. So if we say a subset of concepts at any point in time, that can be slightly different from release to release. So we need to take that into mind as well. And finally, the actual validity of our ECL expressions and the categorization process, that can change over time. And it's important to be responsive to that to make sure that you get the results that you want. So the naive approach is to just do nothing. And here I've got showing a comparison of our aggregation categories using the 4 different releases to do that analysis. So this is using the same data set, but we're using different additions within the terminology server to aggregate the data. Some of them, there's not huge change, but others there is. So there'll be more evident on the later slides, but even just from this, you can see that we've had in our most recent release, for some reason, we've had a jump in the drowning concepts. And this is encounters that were categorized as drownings. We've had a drop off in our objects and forces. And as a result of these, there's also been an increase in uncategorized patients. So these are patients that didn't match any of our categories. They previously did, but for some reason, we've got a lot more now. So I've described these as, there's 3 general patterns to think about here. So what we really want is stable results, regardless of the addition we're using. And we can see this with our transport, assault, and medical accident categories. Apologies if you can't read this, but the idea is more the impression of these graphs rather than the specific numbers here. But we can see here that on our x-axis, we've got the 4 different releases from left to right, and we've got a nice flat line. We're getting the same sort of results, regardless of which addition we use. The next pattern I've called a one-off change, and this is typically when there's been a single addition that introduces some sort of change. And this is particularly most recently a result of the quality improvement changes at SNOMED International, where there's been a project that has done something and it's caused a one-off change to the data, and we end up with things like this. Most of the time, well, from experience, I've noticed that these are typically, we lose patients, so lose results, which you can see on the top right and the bottom 2 graphs, where our results were generally pretty flat, and then we've had a drop where we've lost a number of encounters. And this is just because, again, either inactive concepts or changes in hierarchy, these encounters have fallen out of our categories. But the anomaly here is probably the drownings. There's been a substantial increase from with the numbers like under 4,000 to over 9,000, and I'll get to what that was later. And the final pattern is just unstable one, which is similar, but in this case, there've been multiple changes over multiple editions, and these have various impacts. And the most noticeable on this one is our graph on the left. We've got poisonings, where initially we had a substantial drop in encounters that were captured, and then the next release we lost a few more, but then we've gained some in the next one. So superficially, we could say there's been a bit of a correction at the end to recover some of those, but the actual reasons for these, sort of, we won't get into too much here. We'll just sort of say how we can identify them and action them. So first up is we'll handle the inactive concepts. These were concepts that were active at the time of recording them, but they've been inactivated in later releases. But we still want to aggregate them and have them counted within our categories over time. So there's 2 approaches. We've got a data healing approach, which I describe as we're updating the codes in situ. So we identify the inactive codes and find suitable replacements and do that within the data set. And the other approach is to expand the aggregation categories to include codes that may have been included in them in the past. So it's either updating the data or updating the category. Both approaches leverage the historical associations provided in SNOMED, and we can access this through the terminology server through FHIR concept maps, and they've become a really valuable thing to find out both why a concept was retired and also what it's been replaced with. Now, associations are not always one-to-one. You can have no associations for a concept, and there can be multiple. First, I'll just talk about dealing with multiple associations. So for aggregation, it often doesn't matter. If we just want to group, in this scenario, we just want to group each of our encounters into one of the categories we've got. So as an example, with our fall concepts, we had some that were encoded with a fall on or from a ladder or scaffolding. That's been retired because it's ambiguous, presumably, and it's more of those classification things. Fortunately, our historical associations have given us some replacements, and it's possibly a fall from a ladder or fall from a scaffolding. For the purpose of aggregation, I don't really care what we replace it with, because in the end, it's still going to aggregate as a fall. The actual mechanism isn't relevant for this project. Other projects that may be relevant, you might want to identify the ladders or the scaffoldings, but for this purpose, you don't. And the original concept itself was ambiguous in that state. But sometimes it does matter. So there are concepts like we've got a tick bite without infection, this disorder concept. It's been retired now. And again, we've got possible replacements. This time we've got another two concepts, but we've got tick bite disorder and a tick bite of tick event. The most noticeable thing here is that they're from different hierarchies. And so the consideration here is that how these encounters are going to aggregate now depends on our category definitions. Previously for the full concept, they were both events or situations, but here we've got what was a disorder now could be a disorder or an event. We need to, if we haven't got both of those within our aggregation definitions, that can mean that we may or may not count extra patients. So after we've done this data healing process, just updating all of our inactive concepts, how does our data look? It's good to see we've got our assault concepts here. They've remained nice and consistent, and that's what we want the results to be, that nice horizontal line that are consistent over time. And if you can't read the guide here, the blue line is our healed aggregation results, and the yellow line is our original aggregation. Falls, we did have a drop-off, but our after this data healing, we see we've got this nice horizontal line. So it's been really successful here. Some of the other categories are really marginal improvements. You might not even be able to see the difference between the blue and the yellow line. Probably the only one that I will point out here is that we had this jump up in our medical accidents. And as we go through this, you can sort of get some idea of what these reasons are. So what else can we do to improve it? As I mentioned, associations are not always one-to-one. There are some codes without associations. Typically, these are moved elsewhere or non-conformant to editorial rule retirements. Unfortunately, we don't always get an association with them. So you might need to do a bit of investigation. I looked at the concepts that were retired without association and sort of generated a bit of a word cloud to get an idea of it. And I discovered that all of them were exclusively vaccine poisoning concepts. So presumably there was some project to inactivate this content, but they're just gone. There's no idea what to replace them with. And that's, so I've made a choice that I'm going to replace these manually with the concept poisoning caused by a drug and/or medicinal substance. It's a much broader concept, but as far as I'm concerned, that's a suitable replacement for our vaccine poisonings, because that's what it is. It's a poisoning caused by some medicinal product, and that was 202 codes out of our over 3,000 inactive. So it's not a huge lot, but it's enough that it can impact depending on what your patient cohort's like. Next is that inactive concepts are only a small part of the problem. So you might remember from that earlier slide, there was a substantial jump in uncategorized concepts. 3/4 of these, or over 3/4 of these, were still active. So our data healing didn't actually do all that much, and that was noticeable from the marginal improvements on that blue and yellow line there. After we replaced the inactive concepts, we didn't see that much improvement for most. In fact, 10% of the records categorized differently. So just quickly going through some of these examples, we've got things like our first couple here. We've got examples of what are both effectively jellyfish encounters. One was originally a poisoning and then became an animal-related category. The other one for box jellyfish was an animal-related, and now it's become uncategorized. So there's something happening there. And you can see we've got a few. The most common thing is they've become uncategorized for some reason. And then there are some other things like we've got our neurological decompression syndrome at the end, which was within our forces and objects injuries, and then becomes a poisoning with the most recent release. So the explanation for this is that the ECL expansions can be a little different over time. And this is because new concepts are added to the terminology, hierarchies change a little bit, definitions are updated, whole heap of things. So ideally, you expect a little bit of change. So this is all of our subtypes of traumatic injury. There's a lot of overlap between we're comparing 3 editions here. You can see there's a lot of overlap. Diabetes mellitus can be quite different. We've still got to get some concepts from 3 expansions, but the overlap is much different. I think there's a lot of concepts moved out or retired from this content. And then the extreme end is that they can completely disappear. And this is the extreme end where our ECL expansion for allergy to analgesic is now returning nothing. It's still syntactically correct, but this concept's now retired, and so there's nothing left for it to expand. So you need to do some responsive ECL adjustments and compare results between editions, look at the lineage and modify your ECL definitions accordingly so that the results will behave how they should. Just quickly, a couple of examples here. Using the Burns category changes, we've got this concept here, which was something we were aggregating on. This concept here was part of our ECL definition. And so our burn was being counted. In the May 2021 release, our concept actually moved to this new concept here, contact with hot corrosive. So that isn't part of our ECL, so we're not counting this. And additionally, so our original concept lost this one, and we're not counting it in any of its subtypes. So there's that to look into. And some things are just gone. Laser coagulation burn to retina. We can see that originally we were just looking at subtypes of burn, but when we get again to our May release, we've just lost the burn concept. So what happened here is the definition for burn now has been updated to include it's due to a traumatic event. And because laser coagulation burn hasn't been updated to have a traumatic event, it's no longer a subtype. So we can't rely on that subtypes now. We need to say we actually want things that are associated with morphology of burn. And finally, disjoint categories. And these 3 categories are a really good example of there are concepts that can be poisonings, medical injuries, and animal injuries that can fall into all three of those, or any two of them. How we categorize those, the approach that I've used is to categorize them in a specific order and impose disjointness that way. So I'll count my animal injuries first, then poisonings, and finally do medical injuries. Gives you much simpler ECL, but it's more susceptible to change. You can build the disjointness into the definitions, but it's a lot more complicated, but you do get a more robust process result. So how do these results compare now? As you can see, we've got our yellow line here is our improved techniques, and you can see most of these have come out pretty good. We've got horizontal lines most of the time. There's other stories which I won't get into today because it's beyond this talk, but for why these other changes happened. Our drownings is nice and flat now. That ended up being, it was an error with the original ECL, was a bit too inclusive. So we got rid of that, and we actually canned a few more patients. So there's improvements there from the original aggregation. Poisonings and medicinal accidents, that was a bit of a move of concepts from one category to the other. Burns needs a bit more investigation, and the animal-related injuries is a bit strange still. Finally, I just want to introduce Pathlink, which is a tool developed by CSIRO to help with data analytics. It's based on the HL7 fire standard, and it implements functionality to help ease the delivery of analytics with health. It's available on an open source software license, and it provides a user interface to define aggregations. It can connect to existing data analytic pipelines. So you can use it with Power BI, Python, or other things like that to sort of take some of that grunt work away that's specific to healthcare, SNOMED, fire terminologies, things like that. And you can, again, define your ECL value sets, and it will perform the expansions for you. And so that brings me to the end. Sorry for the rush slides at the end, but just to give us some time for questions, and thank you for joining us. If you want to get in touch, our details, and my colleague, I just want to thank John, Michael, and Dion for helping out with this. And thanks a lot.
Attendees, just give us a moment now while we switch from our pre-recorded content so that Matt can address the questions you have been submitting live. And please note that this session will be available on the event platform for the next 3 months. Thank you. Hi everybody, we're live now. So if you have questions for Matt, could you please use the live Q&A in your AirTouch device, and we'll see some questions come up for him. In the interim, I wanted to thank Matt for the presentation. It was very interesting. I've got a couple of questions for you myself. First of all, feedback on the changes in the terminology in relation to the process. So for people that are developing terminology, some food for thought as we develop it, because it's obviously used and, you know, you're seeing lots of changes.
Yeah, I think at the moment you've already produced in the release notes a list of the areas that have been worked on. And I think that's probably an important thing for users to look at that, to get an idea of what areas have changed and to check those against the areas that they're looking at, because without looking at that, you have no idea what has changed. And it's sort of a good head start to know that, all right, there's been a big change in the burns area. I definitely need to review the burns content.
Okay. The jump in drowning, you mentioned you had to change the ECL. What did you find with that? What sort of changes did you have to make?
Yeah, that was after going through this whole process, I realized that the original ECL included a concept, I think it was something like hypothermia, which wasn't supposed to include drownings, but I left it in there because it was interesting in that the results were flat, and then there was some change in the content that caused a whole heap of things to be included, but that stuff was never supposed to be in there to start with. So we tweaked the ECL, and it it adjusted the original line, but it remained flat throughout the whole set of analysis. So that was good. But yeah, there can be changes on both ends. So it's a good prompt to always revisit your ECL. It's not a set and forget.
Good. Now we've received a question from Valentine, thanking you for the presentation. And is there comparable work done for pre-intra and post-operative incidents?
Nothing that we've done for this. I guess it's just looking at for a single patient. That I guess it's a different project. Sort of, this is more looking at a single result for patient and comparing that result ideally over time using different additions. But yeah, it's a different sort of work that's being talked about here.
Okay. You mentioned some of the areas where you had. I've got another question from Alistair. Let's move to Alistair. Most of the time, do you aim for disjointness in your categories, or do you rely on ordering them? I'm thinking you might miss stuff if you aim for disjointness.
Yes, that's a really tricky one, and that's probably the hardest one. I haven't come down to what the perfect solution is. I think it's a mix of both, and I know some of us within SORA have different views on it. I think, yeah, if you aim for the disjointness, it makes the queries much bigger because they have to rely on each other just to know what's in and out, and yeah, it's a mess. So at the moment, my preferred method is doing it in order. So I know that I want to count the animal bites first and then the poisonings. It just means that the query is a lot easier to manage, but both ways work, and it just, I guess, depends on how many queries you've got. If you've got hundreds, that's a big task. I only had 9 here, so I probably could have coded in disjointness, but yeah, it's that's probably the next thing to investigate, different ways of managing that. And sometimes you do want to count patient in 2 different categories. That's viable as well. So it really depends on the use case.
Okay. So was there any other questions for Matt on this session? Let's give people a chance to. Oh, we have one, do we? Okay, from Robert. Can you elaborate on automated processes used to modify ECLs between versions, or is it mostly manual?
I think it's mostly going to be manual. There's some automated checks you could do to validate the query and check for concepts that have become inactivated or changes in that area. The bit that I found useful through this process was doing those Venn diagrams and comparing that same ECL in additions and seeing what was overlapped. And by doing that, you can then tweak the query a bit and try and shrink those circles to overlap as much as possible. They're not always going to be perfect because there's going to be always new concepts and retirements, but to get that overlap as close as you want, that's I guess how we got to the flat lines for most of those, which is sort of an iterative thing. But yeah, that sort of mechanism was the main one. But yeah, haven't come across an automated way of doing it yet.
Okay, we've got just over a minute left, so I might wrap it up there so that people can start to move to the next session. Before you go, just a reminder, in your AirTouch device, there is a support button. So use live support. So if you've got a question and you can't navigate around the screen, please contact live support and they'll help you make more of the expo. And Michael's just popped a question in there. Matt, I'll let you have a look at that one, but we're going to need to end the session. So.
Yeah, so yeah, Michael's just saying that there is some new enhancements coming to ECL that will help with using historical associations. But yeah, I think that the takeaway is that he's saying you can't fully automate these things.
Thanks.
We can leverage what's there.
Thank you, Michael. Okay, I will say thank you very much. Enjoy the rest of the expo. Thanks, Matt.
Thanks.